So on Thursday, I asked you to do 2 questions. That was it. I just like do those 2 questions, and then I wanted us to kind of keep them for Monday, for today. Let's think about this. We want to calculate the chemical amount. What does chemical amount mean? Moles. We want to calculate the number of moles of hydrogen gas when 7.6 liters of gas is held in a container at 22 degrees Celsius at a pressure of 125 kilopascals. Did we talk about how to answer this question? Yes. You have to use your magic green sheet. That's right. So R, because this is talking about a gas, and it's not talking about a change in something, right? A change in something, you would have to use Boyle's law or Charles' law or the combined gas law. This isn't talking about a change. It's just saying this. How much of this, right? And it's a gas. What is the value for R? 8.314 what? Liters. Kilopascals. Per 1 mole Kelvin. What that means is if you had 1 mole at a temperature of 1 Kelvin and a pressure of 1 kilopascal, it would take up a space of 8.314 liters. That's basically what it means. That's what this constant means. Now, remember, we used unit analysis for this, right? What's the unit that we want here? What's the unit that we want? Moles. We're looking for moles, right? So we're looking for the number of moles. Are we going to start with this constant looking the way it looks right now?
No.
We got to flip it. 1 mole Kelvin over 8.314 liters kilopascals. And what do we have to do to get moles by itself? There's a unit here I love, and there's 3 units here that I despise right now. How do I get rid of them? Which unit do you want to get rid of first? Kelvin, liters, or kilopascals? Kelvin? Sure, let's get rid of Kelvin. So 1 over, what is this temperature in Kelvin? 295 Kelvin, right? Do you remember how to do that? Oh man. Okay, 295 Kelvin. So Kelvin and Kelvin cancel out. And then we just have to multiply by liters and kilopascals. So 7.60 liters. And then 125 kilopascals. So kilopascals, liters, I'm left with moles. Somebody tell me, this is a nightmare, I didn't give myself enough space. Somebody tell me what do I get? And we can wait all day. Is it a good thing we're reviewing this right now? Or would you have rather me just thrown you to the wolves? Throw me. I'm ready. I don't even want to do this. 3, 1, 8. I don't know, is it 0.2 moles or something like that? 0.38 moles. Good. 0. Okay, so how many significant digits do we have? 3. We have 3. Why 3? Because Celsius sucks and we always use Kelvin, right? So we're actually measuring 3 digits here, right? When we measure 22 degrees Celsius, we're actually measuring 3 digits. So it's 0.387. 387 moles of hydrogen. Good, no problem. No problem, whatever, no problem. Are we okay with that? Can I get you to do the second one, please? Confirm with your friends if you've already done it. Confirm with them and see. And then I'm going to start handing out something else. Uh-oh. Would you like that?
We're going to do another test because we have 2 units after this.
Any questions?
I love you.
Thank you. Okay. It says predict the chemical amount of methane gas present in a sample that has a volume of 500 milliliters at 35 degrees Celsius and 210 kilopascals. First of all, I want you to try and take a look at this. This is a gas, right? What units do we like to deal with gas properties in? Do we like milliliters? No, we like liters. Right? Do we like degrees Celsius?
No.
Son of a gun, we like Kelvin. So what's this in Kelvin?
308.
308 Kelvin. And do we like kilopascals?
Yes.
Perfect. So when I go, I'm looking for the number of moles of this gas. 1 mole Kelvin over 8.314 liters kilopascals. What do you want to cancel out first? Sure, Kelvin. All right. Kelvin, should I put it on the top or bottom? Bottom. 308 Kelvin over 1. Perfect. Kelvin's canceled. What do you want to cancel out next? Liters, sure. 0.500 liters over 1. Liters are canceled out. And then 210 kilopascals over 1. kPa, kPa, Kelvin, Kelvin, liters, liters. We're left with moles, right? So somebody on your calculator, don't make me bust out my illegally downloaded calculator. Wait. 4.10 times 10 to the negative 2 moles.
Yes.
Are we happy with that? Yeah? Happy? Boom. You know how to do gas stoichiometry.
That's it?
Well, no. But with that, and with everything we've learned so far, this should be super easy for us to be able to perform gas stoichiometry. So I just handed you out a sheet. The sheet says 7.3 gas stoichiometry. Now, there's two ways to get the moles of a gas given its temperature and pressure and volume and all that kind of crap, okay? There's two ways. The first way we can use that R value. The second way is if we recognize that the gas is under very specific conditions. What are the two types of conditions that are very specific? STP and SATP. Do you remember what STP stands for?
Standard temperature and pressure.
Standard temperature and pressure. And what is the temperature under standard temperature and pressure? What is the temperature under standard temperature and pressure?
0 degrees Celsius.
Aku, do you know it's 0 degrees Celsius?
No.
Say there.
Yes, it does. Yeah. Yeah. Sorry, no. The reason why I'm saying that is because people guess. People just guess all the time. Oh, STP. Oh, yeah, I'm pretty sure that was 25 degrees Celsius. No, it's not. It's 0 degrees Celsius, right? What's the pressure under STP? 101.325 kilopascals, right? Now, standard ambient temperature and pressure is something totally different. It's 25 degrees Celsius or 298 Kelvin. And then it's also 100 kilopascals, right? Okay. So, what I want to know, there's something else to do. Search your sheet for something else that has STP written on it. Is there anything else that has STP written on it? On the next page? No.
Oh, there's the volume one.
Not the volume. Oh, SE.
The V. I can tell.
How many people need a magic sheet?
Give one to Maddie.
I have one.
You have one?
I have two, actually.
You have two? Then give me mine back.
Sorry.
If you have two, that means you owe me one.
Oh, I think I took it from a test.
Yeah, that means you owe me one.
Oh, do you want it?
Yeah. You're supposed to
It's
give
right
them
here.
back. Anybody else need magic sheets?
Miss you wrote on it.
No? Nobody else?
I remember you did this in the middle of the You just did it in the middle of this. Did you rearrange it on here?
Okay, let's think about this. What does SATP mean?
Standard atmosphere temperature and pressure.
Standard ambient temperature and pressure. Yeah. Yeah, standard ambient temperature and pressure. And what I want to know is, can you get moles from something to do with SATP?
Yes.
What is the relationship at SATP between moles and anything else?
Liters.
Moles and liters, what is it?
24.8 liters.
Good. This means every 1 mole of gas occupies how much volume?
24.8.
24.8 liters. So if you wanted to get moles out of this, what's the only thing you got to do? Yeah, put moles on top and cancel out liters, right? So if I had hydrogen gas that occupies 16.4 liters under SATP, sure, you want number of moles, and I know that every 1 mole occupies 24.8 liters. Do we have 24.8 liters? No, we have 16.4 liters. I don't know why, but my equal signs have been really bad lately. So this is going to be less than 1 mole, right? It's going to be about 75% of a mole, something like that. Sorry, 67% of a mole, something like that.
0.66.
0.66 on the nose?
No, 661.
0.661. So, okay. 0.66 what?
12903.
Moles. Okay, how many significant digits do you want?
3.
Is the 661 going to stay as the 661?
Yes.
Yes, good. How easy was that?
Very.
Easy peasy lemon squeezy. Do the next one for me, please.
Why did you give us so much room for that?
What?
Why did you give us so much room for that one question?
I don't know. That's the way the slides worked out. Yeah. Oh, goodness, that's great. What?
Temperature. I'm not mad.
You can get mad at me. That's totally fine.
Okay. Given temperature, which I think is K.
Using the
Disgusting life.
I don't know. Are we under SATP or STP?
No.
No. So
It's
yes,
literally
you have to
this.
use the R value.
Oh, look at you. So, let me erase my K. Okay. Okay, this is, wait, which one is it?
You need temperature.
And you have pressure, oh, okay.
Oh, yeah.
Pressure's key, anything.
It says atom pressure up.
So remember, we're not dealing with a change in anything, so we can't use P1, V1, P2, V2, or whatever, right? We have to use the R value.
Oh, okay, so we're using the R.
Is there a change in anything up here? Do you see anything changing? Is pressure changing? Is temperature changing? Is volume changing? Is the number of moles changing? No, so you can't use any of those, the P1, V1, or P2, V2, or T1, V1, or whatever. You have to use the R value. Shot.
Yes.
Yes. Question.
Yes.
Yeah.
How long is not saying this?
So, we use this.
There's
This
no
can
tally.
cancel everything else.
I thought that just for this one.
Yeah,
I'm missing
just for that one.
letters.
Yeah, what about that one? There's no.
Yeah, I know it's not under STP.
Oh,
What
SATP.
yeah, what temperature does SATP? 25 degrees Celsius, okay? And what pressure does SATP? 100 kilopascals. Are we at 100 kilopascals? No, so we're not, we can't.
Like, it's so bad now.
We have to be under both of these conditions to be under this.
So KPA,
So, okay. You have a gas. The gas, you want to know what temperature, okay? Look here. Is there anything related to temperature inside? Kelvin. All you have to do is cancel out moles, liters, and kilopascals. That's all you have to do.
I'm actually listening today. Okay, wait. I have a question.
Okay.
The answer you get is that in K already?
Well, the answer you get from the R constant, what unit would it be in?
K. Yeah. It would be K.
Okay. What unit do we want out of this? You want Kelvin, right? So we just got to cancel out all the other stuff. Moles, is moles going to go on top or bottom? Bottom. 0.750 moles. Is liters going to go on top or bottom? Top. 0.350 liters. Is kilopascals going to go on top or bottom? Top. Kilopascals, moles, liters. We're left with Kelvin. So just put this, everybody put this into their calculator if you haven't already done it. If you have done it, then you don't need to, right? But put this into your calculator and confirm that we all get the same number. There's a reason why I don't just tell you what the answer is. One, I'm lazy. Two, I want you to do it. Okay? What's the answer?
3.92.
3.92?
That was I think, yeah.
But I rounded it, so.
3.93 Kelvin?
Yes.
Yeah.
Yep. Okay, so this gas is at a temperature of 3.93 Kelvin. Sure, no problem. And then I just want you to do the last one. Just do the next one. This question should legitimately take you a maximum of 30 seconds to finish. Because this is now the third question in a row that we've done that was exactly like it.
I got it. Wait.
I don't know, is it between 800 and 900 kilopascals?
830.
832.
We're gonna
That's-
be 8.3.
But you should put
Wrong.
0.7.
8.3 minus 10 to the
Are we getting used to me being a jerk about that? You're anticipating me saying, that's wrong, ahead of time. That's fantastic. Okay, all of this work just to now start gas stoichiometry. We haven't even started gas stoichiometry yet. All we did was we reviewed how to get moles. That was from unit number, that was chapter 4. Chapter 4 in your textbook, so it was chapter 4 in our notes. Yeah.
So we're doing that through moles, and does this give moles to moles?
Yes. That's exactly right. What is stoichiometry all about?
Moles.
What is stoichiometry all about?
Yes.
No. It's about going from one thing to another thing, right? So if I had 3 moles of A, how many moles of B would I produce? 6 moles, right? Boom, that's stoichiometry. That's all stoichiometry is. How did you know that 3 moles of this would make 6 moles of this? Because of the molar ratio. It's not just the 2 out in front, Idris, right? It's the fact that 2 of these are made for every 1 of these. It's that molar ratio. And so all we have to do when we're doing gas stoichiometry, remember, we have to find the moles of one thing, use the molar ratio to turn it into another thing, and then once we have the moles of this, we can figure out anything we want. We can identify any conditions that we care to. Example, what volume of oxygen at STP is needed to burn 15 grams of propane in a barbecue burner? The first thing I want to say, what's always our first step in a stoichiometry problem? Write a balanced chemical reaction. Because you don't know how much of this is going to make this, right? You don't know how much of this needs that. So what is the burning of propane? What's propane? We're making a balanced chemical reaction. Now, when you burn propane, what do you have to react it with? And what do you always make? Carbon dioxide and water vapor. So now let's balance this chemical reaction. The oxygens are always a son of a gun, aren't they? Yep. Once you get a balanced chemical reaction, just look up at the front. We should get a coefficient, I'm not telling you any of the others, but we should get a coefficient of 5 in front of the oxygen. Just see where, if and where maybe you messed up. Okay, why? Why 5 oxygens over here?
3 and 2.
Because 3 and 2 make 6, and 6 and 4 make 10, right? Yeah. So we need 10 oxygen atoms, but they come in groups of 2, so we need 5 oxygen molecules. Okay, no problem. Okay, what's that like part 1b? Are we done step 1 for stoichiometry yet?
Yes.
Nope.
That's
Not
what
really.
I said.
It's you're done if you want to be done.
The information.
But if I was doing this chemical reaction in a stoichiometry problem, I would put all the information. What's all the information you know?
15. What
You want to know what volume of oxygen. Now, when I say volume of oxygen, what should immediately pop into your head? At what temperature and pressure are we talking about? We are under standard temperature and pressure. This is such a huge shortcut. If you ever see this, be super happy, be super thankful. We don't need to use the R value for this. Let me think about it this. Let's finish putting the information and then we'll come back to it, okay? What other piece of information do you see in here? 15 grams. Who does that belong to?
Propane.
The propane. So 15 grams of this stuff. Okay, let's think about this. I want my molar ratio. What's my molar ratio? It's always
Unknown.
so 5 moles of oxygen are used up for every 1 mole of propane. I'm just going to put that off to the side just because we're going to need it. We know we need it eventually. Okay, remember, stoichiometry, pay attention to me for a second. Not because I love the attention, but because this is important. Stoichiometry is always about moles of this and moles of that. Can you get moles of this substance from this? What do you need? You need the molar mass because it's a mass. So go ahead and calculate the molar mass.
Thank you, Maddie.
Yeah, thank you, Maddie. You should get 44.11.
Yes.
Okay. Let's use kind of our mind mapping abilities and let's kind of guide us through this problem. We're gonna start, or we're gonna end with whatever, but we can go from mass to moles using the molar mass. And then once we have the moles here, where can we go from there? To moles of O2, right?
Mm-hmm.
Once we have the moles of O2, how can we get volume from moles of O2? What are the two different ways we can do it? Wim, give me one. Moles per liter, but that's only for aqueous solutions, right? Moles per liter is just concentrations. I mean, sorry, I don't mean to say it's only for aqueous solutions, but it's a concentration. Do you know the concentration of oxygen? No, we don't. Okay, so we can't use moles per liter. How are moles and liters used? Oh, Wim, maybe your question... Sorry. Maybe you were totally right. What do you mean by that? What do you mean by moles per liter? Yes, okay. Sorry. I thought when I hear moles per liter, I mean molar concentration. But it's not moles per liter here, it's liters per mole, right? For gases. How many liters does 1 mole of gas occupy at STP?
22.4.
Good. 22.4 liters. So now, is it possible for us to go grams to moles to liters? Can you see how this is going to work? Yeah. I don't know, hopefully you can. Okay, what do we always do? We always start with,
What you want?
we're looking for the volume measured in liters. Is there anything in here that says liters?
Yes.
That's great.
So I would say 22.4 liters of oxygen for every 1 mole of oxygen. And then we want to cancel out moles of oxygen, and we can use our molar ratio. 5 moles of oxygen for every 1 mole of propane and propane accessories. And then 1 mole of propane can get canceled out by the molar mass. 1 mole of propane is 44.11 grams of propane. And then we have 15 grams of propane. Is this not exactly the same thing as we were doing with, but now we're including properties of gases, right? This is what we call a molar volume. This isn't a molar concentration, this is a molar volume. So once you've done this on your calculator, let me know what it is.
7.6 liters, I think.
7.6 liters of oxygen.
I got 38.
Ooh, good. That's okay. But this is why we want everybody to do it all together, right?
Wait.
What did you get? 38? 38.08. So 38 liters of oxygen.
I forget them.
That's okay. Okay. When I look at this, if you want to burn, is this a surprise to you? How much is 15 grams of butane or propane? Is that a lot? 15 grams of something? No. Every time you turn on your barbecue, when you go to burn 15 grams of propane, how much oxygen do you steal out of the atmosphere? You steal 38 liters of oxygen out of the atmosphere. I don't know, to me that sounds like a lot, but that's fine, that's okay, that's whatever. We got time for at least one more problem. Again, I want to make sure you understand, stoichiometry is all about taking moles of one thing and turning it into moles of another thing, right? Yeah, are we at STP or SATP? We're gonna have to use the R value. This is gonna be complicated, but it'll be fine. Okay, what? Do you want me to walk you through the first little bit?
Yes.
Okay, what's the first step in a stoichiometry problem? You gotta get a balanced chemical reaction. First of all, let's see, is this actually a stoichiometry problem? What volume of ammonia can be obtained from the complete reaction of hydrogen? Is it talking about one thing, but then asking you about another thing? Yes, that's a stoichiometry problem. Yes, you need a balanced chemical reaction. Okay, so what volume of ammonia? How do you think we make ammonia?
Nitrogen.
Yeah, probably nitrogen and hydrogen, right? N2 gas plus H2 gas. How do I balance this? Three,
And
2, and we're good, right? Good. Okay, once we have our balanced chemical reaction, now all we have to do is start putting our little pieces, our puzzle pieces, below where they belong. What volume of ammonia at 500 kilopascals? So where would I put 500 kilopascals? I would put it under ammonia, because you want volume, right? And volume and pressure are related to each other. So I would put 500 kilopascals and 80 degrees Celsius. Are we happy with that value? No. 353 Kelvin. Can be obtained from the complete reaction of 7.5 kilograms of hydrogen. Where's that going to go? What other piece of information is never going to be given to you in the question, but you should always write it down? The molar ratio. What's our molar ratio? Yeah. Well, we're looking for volume, right? So it's going to be 2 moles of ammonia over 3 moles of hydrogen. Do we have all of our information to be able to try and do this?
No, we need molar mass, you can say.
Okay, let's think about this. In order to go from mass to moles, what do we need? The molar mass. Find the molar mass of hydrogen for me.
200.
Okay. So now, can we successfully go from mass to moles of this substance?
Yes.
Yep. And then moles to moles. And then from moles, and once we cancel out kilopascals and Kelvin, what can we get? Volume. What other piece of information do we need? But you don't have to write it down. What other piece of information relates moles? It's not molar mass, because do you see anything around here related to mass?
No.
We're going to get moles, right? We're going to get moles, but we don't want mass, so molar mass is out. Not a molar volume, because molar volumes are only at STP and SATP. We need that R value, right? Yeah. Okay, so what are we looking for? We're looking for the volume measured in liters of ammonia. And remember that R value, I'm just going to put it off to the side, is 8.314 liter kilopascals per 1 mole Kelvin. So how do you want to write it? Do you want to flip it?
No.
No, because you want liters. I'm going to have to give myself a lot of room for this, because this is going to be a big reaction and I don't have very much room. So 8.314 liter kilopascals over 1 mole Kelvin. If we want liters, what's the only things we have to cancel out? We can cancel out kilopascals. So 500 kilopascals. What else do you want to cancel out? Kelvin and moles, right? Let's do Kelvin first. So Kelvin was 353 Kelvin. So Kelvin and Kelvin, kilopascals and kilopascals. Now remember, we want liters, so we have to cancel out moles. What moles am I canceling out?
I think hydrogen.
Where did you, what gas are we talking about here? What volume is this gas related to? This is moles of ammonia. So what do we have to cancel out? You have to cancel out moles of ammonia using our molar ratio. 2 moles of NH3 over 3 moles of H2. Then we can cancel out moles of H2 using the molar mass. .02 grams of H2, and we started off with 7.5 kilograms of H2. Remember at the beginning of the semester and you laughed at me when we had like 7 things canceling out? Let's see. What cancels out at the very end? What's the very last thing to cancel out? Grams of H2, moles of H2, moles of NH3, moles of NH3, and we're left with what? What units are we left with? Kiloliters. Every kiloliter is 1,000 liters. So we should get an answer measured in kiloliters of ammonia. 14 point what? 14.52?
Yes.
Is that what other people got?
Yeah. Yeah,
14.52 kiloliters of ammonia. I mean, obviously you know what I'm about to say.
I changed it.
That's wrong, right? Is it, Kylan, is it supposed to be 5.3?
Yeah.
Doesn't matter, does it? Yeah, it's 2 digits, right? So it's going to be 15 kiloliters of ammonia. Again, the one thing I want you to focus on, what is stoichiometry all about? The moles of one substance to the moles of another substance. Doesn't matter how you get there as long as you get there. I want you to focus on one thing. Don't put your stuff away yet. All of this first stuff had to deal with ammonia. All of this last stuff had to deal with, the hydrogen. And anything in between is just the molar ratio, right? All we're doing here, we're calculating moles of one thing, using the molar ratio, and turning it into moles of another thing. That's all we're doing. That's all we ever do in stoichiometry. So as long as you're properly labeling your units, things will work out fine. Tomorrow, we're going to do some more gas stoichiometry stuff. Yeah, fun, super fun. We're going to do some more gas stoichiometry stuff. And we're going to get ready for solution stoichiometry. And you're going to have a quiz on Friday. No, Thursday. You're gonna have quiz on Thursday.
That lab.
Oh yeah, the lab quiz is tomorrow, right?
And then a quiz on Thursday.
Yeah, then you're gonna have a quiz on Thursday. So Chem 20, you got that lab quiz. And then on Thursday, you're going to have a stoichiometry quiz.
Because I'm going to my cousin's Okay. Well, what do you want me to say? Like, do you want to die? Bring some spice into it.
Hello, how are you, Boris?
Good. You're still walking?
Mm-hmm.